October-November 23, variant 33. It's an enthalpy change question using Hess's law. You will determine the enthalpy change for the reaction of magnesium oxide with water to form magnesium hydroxide as given in the equation. The procedure will involve two experiments, one with magnesium oxide and the other with magnesium hydroxide. In each case, you will react the solid with hydrochloric acid. And the chemicals given are Fa6, magnesium oxide, Fa7 is 2 molar hydrochloric acid, Fa8 is magnesium hydroxide. Apparatus and chemicals given are Fa8 and 6 are solids and Fa7 is aqueous solution. 50 cm³ measuring cylinder, 250 cm³ beaker, 2 plastic cups and a thermometer. Part A. Experiment 1 is the determination of the enthalpy change of reaction delta H1 of magnesium oxide with hydrochloric acid as given in the equation. The method says support a plastic cup in 250 cm³ beaker. Support the plastic cup in 250 cm³ beaker. Use 50 cm³ measuring cylinder to transfer 30 cm³ of Fa7 into the plastic cup. Measure and record the temperature of the solution in the cup. Using 50 cm³ of measuring cylinder, transfer 30 cm³ of Fa7 into the plastic cup. So it's 30 cm³ of Fa7 transferred into the plastic cup. Now let's observe the temperature. Before observing the temperature, let us see the least count of our thermometer is 1 degree Celsius. It means there are 10 divisions in between 20 to 30, so we can say the least count is 1 degree. So the error of this in thermometer is 0.5. Therefore, we have to record every temperature till 1 decimal place, either ending at 0.0 or 0.5. Well, in this case, the temperature is 29.0 in exact. So the temperature is 29.0. The next point says weigh the container with Fa6 and record the mass. So the recorded mass is 29.27 grams. Tip all the Fa6 into the cup containing Fa7. Fa7 is in excess. It means here in this part the hydrochloric acid is in excess. Stir the mixture until the maximum temperature is obtained. Record the maximum temperature. So let's perform this now. Let's add Fa6 and stir the mixture until the maximum temperature is recorded. Keep stirring and looking at the temperature. So it's 29.5 now. It's 29.5 still. Again. It's not increasing more than 29.5. So just half degree rise is there. So let's record this observation. So the maximum temperature observed is 29.5. Now the next point says weigh the container with any residual Fa6, record the mass. So the residual Fa6 with container has the mass 28.37. Now the next point says calculate and record the mass of Fa6 used. Obviously it can be calculated by subtracting this value with the initial value. Calculate and record the temperature rise. So this value of temperature rise can also be calculated by subtracting these two temperature values. Now all of this is to be recorded here in a form of proper table in the space provided. So let us form a comprehensive table recording all these observations. So I have recorded all the observations in the form of a proper table here. Now let us proceed on to the next part, which says calculate the energy released in your experiment. So the formula for the energy released we have studied is E is equals to mc delta T, where m is the mass of solution or mass of water. Here in this case, the only solution or the aqueous phase we have used was HCl. If you look at the equation, magnesium oxide solid is reacting with hydrochloric acid aqueous. So the aqueous phase is just HCl, and HCl, which is the Fa7, is taken as 30 centimeter cube. So the volume of aqueous phase is given as 30 centimeter cube. Now, how can we write the mass out of this volume? For that, remember, density of water is 1 gram per cm cube. 1 gram per cm cube means for every centimeter cube of water, it's equals to its grams. So if we have here 30 centimeter cube of aqueous phase used, it means the m is 30 grams. So multiply this 30 with, now C. What is C? C is the specific heat capacity, specific heat capacity of water. Now specific heat capacity of water is a constant value which is given on the last page of this paper, that is 4.2. Multiply by the delta T, which is the temperature rise. Here we have seen it was 0.5. So this is how we will calculate the energy released in this experiment. The value of this answer is 63 joules. Now let's proceed on to the next part. Now the next part says calculate the enthalpy change for the reaction delta H1 in kilojoules per mole of magnesium oxide. As we have read in the method that magnesium oxide was the limiting reactant and the hydrochloric acid Fa7 was the excessive reactant. So obviously the enthalpy change here will be calculated on the basis of magnesium oxide. So in this case, when we want to calculate the enthalpy change, the formula of enthalpy change is delta H is equals to energy over 1000 to make it in kilojoules, multiply by the number of moles of limiting reactant. Here in this case, we add the sign ourselves. The delta H is either positive or negative. Now, remember that if temperature is rising, temperature increases or rises, it means it shows exothermic reaction that is represented by a negative sign. And if temperature falls means the reaction is endothermic and it is represented by a positive sign. So in this case, our temperature rose by 0.5 degrees. That's why we will take this value as in negative. And we have to write the sign here and in these parts the sign is represented separately, so that you will remember that you have to put a negative sign or positive sign. Now the value of E we got in the previous part was 63 divided by 1000 into number of moles of limiting reactant, and the limiting reactant is MgO. So now how to calculate the moles of MgO? If we look at the previous page, the mass of MgO was used. Fa6 was the MgO, and the mass of MgO, here is Fa6 MgO, and the mass of Fa6 used was 0.9 grams. So when we have mass in gram, we can calculate moles from it. How? The formula for that is mole is equals to mass in gram divided by the mR of the compound, and here we have mass recorded as 0.90 grams of magnesium oxide. Its mR can be calculated as 24.3 is the AR of magnesium and 16.0 is the AR of oxygen. Well, in this case the recorded moles will be 0.02233 moles. Now let's put this value in the formula above, multiply by the moles are 0.02233, and we will put a negative sign here for exothermic reaction. Now here if we calculate the value is 2.82, and the sign must be negative to show the exothermic reaction. Now let's move on to the next part. B says experiment 2 is the determination of enthalpy change of the reaction, that is delta H2, of magnesium hydroxide with hydrochloric acid according to the equation. Method: place the other cup in the beaker. Use 50 centimeter cube of measuring cylinder to transfer 30 centimeter cube of Fa7 into the cup. Measure and record the temperature of the solution in the cup. So let's record the temperature first. Now place this plastic cup into 250 centimeter cube beaker, and using this measuring cylinder transfer Fa7, that is 30 centimeter cube. .30 centimeter cube of Fa7 is transferred into the cup, and measure the initial temperature. Wait 20 seconds to stabilize the temperature. Now the temperature is recorded as 29.0 again. So the temperature is recorded here, 29.0. The next part says weigh the container with magnesium hydroxide Fa8, record the mass. Now the weight of magnesium hydroxide Fa8 with container is 30.86. The next point says tip all the Fa8 into the cup containing Fa7. Fa8 is in excess. So this time it's not hydrochloric acid, it is magnesium hydroxide which is in excess. Stir the mixture until the maximum temperature is obtained. Record the maximum temperature. So let's do it now. Now let's dip all the Fa8 into this plastic cup and stir to record the maximum temperature. Temperature is rising rapidly, you can see. It has reached up till 53.02 now so far. It has reached a maximum of 53.0 degrees Celsius. Not increasing anymore, rather start decreasing now. So the maximum recorded temperature is 53.0 degrees Celsius. So the maximum recorded temperature is 53.0 degrees Celsius. Now weigh the container with any residual Fa8 and record the mass. Mass of container with any residual Fa8 is 28.40. Now calculate and record the mass of Fa8 used and calculate and record the temperature rise. Again, we will form a table here in which we will record all the observations and the mass used and the temperature rise. So in the form of table, all the values and observations are recorded. Now let's move on to the next part, which says calculate the enthalpy change delta H2 in kilojoules per mole of magnesium hydroxide for the reaction of magnesium hydroxide with hydrochloric acid. Show your working. First of all, we will calculate the energy given off. So E is equals to mc delta T. Again, mass of solution which was taken in the method was 30 centimeter cube of Fa7. And that is the only aqueous thing used. The other thing was solid. So 30 centimeter cube means 30 grams we will take here. So 30 grams multiply by the C is constant 4.2, and the delta T we have calculated in the previous part was 24 degrees Celsius. So we will use 24 degrees Celsius here. So if we multiply all these values, the energy will be 3024 joules. The formula of enthalpy change is delta H is equals to E, which must be taken in minus here also because the temperature was rising, exothermic reaction, divided by 1000 into number of moles of magnesium hydroxide in this case. Why? Because they have asked you for magnesium hydroxide, per mole of magnesium hydroxide. Therefore, we need to calculate the moles of magnesium hydroxide used in this reaction first. If we look at the previous page where they have said magnesium hydroxide, that was Fa8, was used in excess, and therefore the Fa7 was a limiting reactant. So we need to calculate the moles of Fa7 first, and as in reference we use equation to calculate the moles of MgOH2 reacted. So in this case the moles of HCl can be calculated from its concentration. The volume is 30 centimeter cube and the concentration is given on the first page in the introduction as 2 moles per dm cube hydrochloric acid. So the concentration is 2 and the volume we have used is 30. So the formula of moles is concentration is equals to amount in moles upon volume in decimeter cube. Now the volume we have taken was 30 centimeter cube, so divided by 1000, and the concentration we have seen was 2 moles per dm cube, so 2.0. Now in this way we will calculate the moles of HCl used. So moles of HCl is equals to 0.06 moles used. Now according to the equation, if we look at the equation, the ratio of HCl to MgOH2 is 2:1. So HCl to MgOH ratio is 2:1. Therefore, the moles of HCl will react with how many moles of magnesium hydroxide here? So here the moles of magnesium hydroxide will be 0.03 moles. So in this case, the formula has the values to use. Minus E means 3024 divided by 1000 into the number of moles of MgOH, 0.03 consumed, so 0.03. So the value of delta H in this case is minus 100.8 kilojoules per mole. So here we will write minus 100.8. Now let's move on to the next part, which says use your answer to A3 and B2. So this was the answer in B2, which was delta H2, and the answer for A3 was delta H1. To calculate the enthalpy change delta HR in kilojoules per mole for the reaction between magnesium oxide and water, whose equation is here. So now in this case we have to use the Hess's law. How we will use this Hess's law? Let's write the equation for part A3 value and the equation for part B2 value. So the equation for part A3 was magnesium oxide with hydrochloric acid to form magnesium chloride and water, whose delta H we have calculated was in A3 part as minus 2.82. So let's write these two things first. So here I have written the equations for both the reactions of magnesium oxide and hydroxide with hydrochloric acid we have done, and the value we have calculated in the previous parts. Now in order to use the Hess's law in this part, we need to look at this magnesium oxide here and magnesium hydroxide here, which are both in these equations as magnesium oxide and hydroxide, and they both are reacting with HCl to form the same thing, MgCl2 and water. It means if we draw a Hess's law cycle, we will make it react with HCl to form magnesium chloride and H2O. Exactly this way, this magnesium oxide is also reacting to form this. Now 1 mole of magnesium oxide when reacting with HCl gives you minus 2.82. So we will take here minus 2.82 for 1 mole, and for magnesium hydroxide 1 mole we have calculated as minus 100.8. So here it is minus 100.8. So in this case we will take out the value of X here in this way, that we will look at the direct and indirect route. So to look at the direct route, we can see the arrow from here is coming down. It is the direct route, and the arrow from here is going there first and then coming down. It means the indirect route. So we will take this value as indirect route. Minus 2.82 is the direct route, and the sum of indirect route is minus 100.8 and X. So the value of X here will be calculated as plus 97.98. So in this calculation we have seen the sign is positive, which means endothermic, and 97.98 kilojoules per mole is the value. So here we comes to an end of 12 marks enthalpy change question using Hess's law from October-November 23 variant 3.3.